Hello everyone. Good afternoon. I'm audible, right? Good afternoon. So we'll start our session. So this is very important session, right? And this is the last session on straight lines. So if you haven't watched the previous videos on direction cosines, direction ratios, planes, and the last three videos on straight lines, so please go through that and watch this video, right? Because then only you will have more conceptual understanding. So in this class, we will be solving 10 to 12 problems. That is based on all the previous concepts, right? It involves plane, it involves direction ratio, it involves direction ratio, cosines, it involves equation of straight lines, it involves planes. So we're going to do 10 to 12 problems that is based on all the previous classes, and it is purely based on straight lines only, right? So we will start, we will be doing 10 to 12 problems in this class, and then we will be winding off straight lines, right? I already given the question bank for direction, cosine, direction ratio, and planes, right? So go through all that and practice all the problems that is in Telegram group. And after this session, I will give you the question bank for straight lines, right? Now solve those problems also. And if you have any doubt, you can text me in Telegram. In this week, we will have a cumulative test, right? In this week, we will have a test that consists of DCDR, planes, and straight lines. These three are one set. Next will be sphere, cone, that is different set. But these three all are based on that DCDR. It is only mixed only, right? All three are. So we will in this week we will have a test series that is based on DCDR, planes, and straight lines, right? So this is the last session on straight lines. I hope there will be no doubt from the previous classes. So we will be doing 10 to 12 problems in this class. All are very easy problems only, right? You just if you have the conceptual understanding of all the previous classes, then you can do any problem, right? So for analytical geometry point of view, you need to have conceptual clarity. Then you can easily get the answer. Just draw the diagram, write the known formula which you already know, make use of DCDR, you'll get the answer. That's it. Right? Even if you don't know, just draw the diagram and try to and make use of all the known formula, you'll get the answer. You'll get at least 5 to 6 marks if you attend analytical geometry. If it is 10 marks question, right? Just draw diagram, write the known formula, just substitute the known facts. Probably you'll get the answer most of the times. If not, you'll get at least 5 to 6 marks, right? So no problem. Analytical geometry is one of the easiest chapter, provided if you have conceptual clarity. Okay, so we will start the first problem in this session. So here we're going to solve 10 to 12 problems, right? So I'm going to split this into 5 different parts, right? Okay, so first I'll write down the question, then we will do problems, right? Yes. So first is very important problem. Find the equation. Find the equation. Find the equation of projection of the line x minus 1 by 2 is equal to y plus 1 by minus 1 is equal to z minus 3 by 4 on the plane x plus 2y plus z is equal to 6. See, we have already done a problem that is based on projecting a point on the plane. Here we are projecting a line on the plane. Yet when we are doing plane section, we have already solved a problem that is based on projecting a point on the plane, right? But here, just a minute. So here what we are doing is we are projecting a line on the plane. So projection of line on the plane is some other line, right? We have a line, we have a plane. So we are projecting this line on this plane. Image will be a line only, right? in exam point of view, they can also ask like find the image of the line on the plane, or they can also ask like find the projection of this line on the plane. Even if they replace this projection by image, same problem only, right? So we are finding the image. We have a line, we have a plane. So we are finding the image of this line on this plane. So image will be a line only. Image of a line will be a line only when we are projecting in the plane, right? So very simple. Let us draw a diagram, then you will have very clear understanding, right? Let us draw a diagram, then you will have very clear understanding. So we have a plane, right? So we have a plane, we have a plane, right? We have a plane, and we have a line, right? And we have a line. Let us say the line is, let us say the line is AB, right? This is the line AB. So we are projecting this line on this plane. So we are going to project this line on the plane. Very simple. The projection of this line is nothing but you just draw, you just draw a perpendicular, right? So this line is the projection of, this line is the projection of this line on the plane. So we need to find the equation of BB dash. So BB dash is the projection of this line on the plane. So in order to find image or projection, you just draw a perpendicular from A to plane, then connect B and this point. That is the projection of this line on this plane, right? They already given this plane equation. So we know P1, right? So we know P1. So P1 is x plus 2y plus z is equal to 6. We are projecting this line on the plane. See, very simple. Just understand this visually. I'm going to find the equation of BB dash in general form. I'm going to find the equation of this BB dash. We need to find the equation of this line, right? Find the projection of this line on the plane. This is the projection, that will be a line. Now we're going to find the equation of this line. The equation of this line can be found in general form or in symmetrical form. If it is symmetrical form means we know, right? X minus alpha by A, Y minus beta by B, Z minus gamma by C, where alpha, beta, gamma is any point on the line. ABC is the direction ratio. Now we are going to find this in general form. What is the equation of n in general form? It is nothing but P1 equal to P2 equal to 0. You will have two plane equal to 0. Yes or no? General form, right? P1 equal to P2 equal to 0. So you have two plane. Intersection is a line. That line equation is given by P1 equal to P2 equal to 0. Right? Now I'm going to find this equation of this BB dash in general form. Right? What I'm going to do is I'm going to construct a new plane. I'm going to construct a new plane. Um, I'm going to construct a new plane. Right? Understand this diagram. Right? I have constructed a new plane. Right? New plane. Let us call this as P2. Call this as P2. Now you can clearly see BB dash is nothing but the line of intersection of P1 and P2. Yes or no? See, you just have to visualize this in 3D, right? This BB dash is nothing but the intersection of the two plane. That is the intersection line of intersection of the two plane, right? BB dash. So that means the projection of the projection the projection of the given line of the given line on the given plane on the given plane in general form in general form is given by P1 equal to P2 is equal to 0. Because general form will consist of two planes only, right? See, what is the equation of line in general form? So you have two plane. This is the equation of line in general form. So you have P1, you have P2. So you have P1 equal to 0 equal to P2. That is what general form, right? Now when you look at this BB dash is this line of, see, this is a diagram which we often draw. But just visualize this with this, right? So you have two plane and BB dash is the line of intersection of these two planes. Visualize this in 3D, right? Don't visualize in 2D. Okay. Now we already know P1. We already know P1, right? Because it is already given. But we don't know P2. So if I found P2, then I can easily find the equation of VB dash in general form. So how to find the equation of the plane P2. So if I found the equation of plane P2, then we have P1 equal to P2 equal to 0 gives the line BB dash equation in general form, right? Yes. Now how to find to find equation of the plane P2. So how to find the equation of the plane P2, right? We are going to find the equation of the plane P2. Now they've already given the equation of this line AB, right? So you can see this in symmetrical form. So this line passes through a point 1 comma minus 1 comma 3, and this line has direction ratio, 2 comma minus 1 comma 4, right? Yes or no? See, this is the line they have given, right? This is the line they have given, which is taken AB. So projection of this line on the plane. So this is symmetrical form. So that means 1 comma minus 1 comma 3 is any point on the line, and this has direction ratio 2 comma minus 1 comma 4, right? Okay. Now we are going to find the equation of the plane P2. Equation of the equation of the plane P2. Now you can see this point lies in P2. What is the equation of plane passing through a point? Equation of plane passing through a point with direction ratio a comma b comma c. So equation of plane, we know that equation of plane passing passing through a point x1 comma y1 comma z1 is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0, where abc is the direction ratio of the normal and x1 y1 z1 is any point, right? Now we know here the point 1 comma minus 1 comma 3 lies on the plane P2. So what is the equation of plane passing through this point? So it is a into x minus 1, b into y plus 1 plus c into z minus 3 is equal to 0. So this is the required equation of P2, but we don't know ABC value. Now how to find ABC? So if I find ABC and substitute back here, I will find the equation of plane passing through a point P2, right? Where A comma B comma C is the, see, you can use small ABC or capital ABC, anything, right? Is the direction ratio of normal to the plane P2. Yes or no? This we already know, right? Okay. Now I'm going to use two important condition here, right? I'm going to use two important condition here. We have now to find the value of ABC. We need two equations in ABC. Then we can easily find ABC by cross multiplication method, right? So to know ABC, we need two equations in terms of ABC so that we can solve for cross multiplication method. Now you can see this AB is a line that lies in P2. Yes or no? AB AB lies in P2. Sorry, lies in the plane P2, right? AB lies in the plane P2, right? This, can I say direction ratio of AB is perpendicular to P2? Because you can see the direction ratio of P2 is, what is the normal of P2? It is perpendicular to the plane. So since this line lies in the plane, the normal will be perpendicular to AB also. See, what is the direction ratio of normal to the plane P2? It is ABC. Now AB lies in the plane P2. That means AB is perpendicular to direction ratio of the normal, right? Direction ratio of normal. Okay. Is it clear? See, very easy problem only, right? I think you can follow, right? This ABC, see, ABC is the normal, right, to this plane, and AB is lies on P2. So that means AB is perpendicular to normal. So direction ratio of AB is perpendicular to the direction ratio of normal also. Now, what is the direction ratio of AB? Direction ratio of the line AB. Now, what is direction ratio of AB? It is 2 minus 1, 4. 2 minus 1, 4 is perpendicular to what is direction ratio of normal of the plane P2? It is A comma B comma C, or capital A comma capital B comma capital C. You can use anything. So that means A1 A2 plus B1 B2 plus C1 C2 is 0. So we have 2A minus B plus 4C equal to 0. Is it clear? See, if it is clear, means just respond, right? So we have assumed that the P2 has direction. Here it is hard to draw the diagram here. Let us say this is the normal to the plane P2, right? So this black line has direction ratio ABC, and this AB lies in the plane P2. This direction ratio is perpendicular to plane itself, and AB lies in P2 only. So that means this AB line is perpendicular to direction ratio of normal. So that means that has direction ratio ABC, this has 1 minus 1 3 as direction ratio. So that means A1 A2 plus B1 B2 plus C1 C2 is 0. So we have got the first equation, right? This is the first data we have used. Now other data is both the planes are perpendicular, right? Yes or no? Both the planes are perpendicular. Now the direction ratio of, what is the direction ratio of P1? What is the direction ratio of normal of the plane P1, which is 1 to 1, right? 1 to 1. And what is the direction ratio of normal for the plane P2? It is ABC. So we have, A plus 2B plus C is equal to 0. Now solve for 1 to find the value of ABC or substitute back in the ABC to get the answer, right? See, we have used two conditions. The first condition is AB is perpendicular to P2. So we know direction ratio of ABC, which is 2 minus 1 4. So 2 minus 1 4 is the direction ratio of ABC, and P2 direction ratio by assumption is ABC, and P1 is perpendicular to P2. So direction ratio of normal to the plane P1 is what? 1 to 1. And what is the direction ratio of the normal to the plane P2? It is ABC. Again, make use of perpendicular conditions. Now solve for 1 and 2. Now solve for 1 and 2. So we have 2A minus B plus 4C equal to 0. A plus 2B plus C is equal to 0. So we have A divided by B divided by C divided by, so minus 1 4 2 minus 1 2 1 1 2. So we will have minus 1 minus 6 minus 1 minus 8 4 minus 2 2 4 plus 1. So we have A is equal to minus 9, B is equal to 2, C is equal to 5, right? So we have A is equal to minus 9, B is equal to 2, C is equal to 5. Now substitute substitute in star, right? Let's call this as star. So the required equation of plane is a into x minus 1, a into x minus 1 plus b into y plus 1 plus c into z minus 3 equal to 0. So what is a? A is minus 9. So minus 9 into x minus 1. B is 2 into y plus 1. C is 5 into z minus 3 is equal to 0. So we have minus 9x plus 2y plus 5z. This is 9 plus 2 minus 15 equal to 0. So 9 plus 2 is 11. 11 minus 15 is minus 4. Let us multiply by minus throughout. This is the equation of the plane P2. This is the equation of plane P2, 9x minus 2y. So therefore, the equation PB dash in general form, right? In general form is given by P1 equal to P2 equal to 0. So the equation of P1 is x plus 2y plus z, x plus 2y plus z minus 6 equal to 0. That is equal to 9x minus 2y minus 5z plus 4. So this is the required answer. See, if they ask in symmetrical form means you just convert this general form to symmetrical form. If they ask in symmetrical form means you convert this general form to symmetrical form, which you already know. So I'm going to do only one problem on this model, right? If they replace this line by some other line and this plane by some other plane, this is the procedure. I'm not going to do more than one problem. See, you just have to understand this concept. In the practice problem, I'll give you more problem like this. So we have a line, right? This is the line they have given, and this is the plane they have given. We need to find the projection. Projection is nothing but draw a line that is perpendicular to A that meets the plane. This is the projection. I'm going to find this BB dash in general form. So I'm constructing a plane, and this BB dash is nothing but the line of intersection of these two planes, which is nothing but P1 equal to P2 equal to 0. We already know P1 equation. Only thing is we need to find the equation of this blue plane, which is P2. So we know this equation of the plane P2 is passing through this point, because we know this is the line they have given. In this line, 1 comma minus 1 comma 3 is one of the point in the line, and this has direction ratio 2 minus 1 4. So this equation of plane passing through this point is given by this formula. Now only thing is we don't know ABC. Now you can see this. I'm assuming that this P2 has direction ratio of the normal is ABC, right? Now the line AB is perpendicular to normal. So this direction ratio, that direction ratio already know. So make use of perpendicular condition. And similarly, this P1 is perpendicular to P2. So we already know this P1 has direction ratio. What's the direction ratio of P1? 1 to 1. And P2 has direction ratio ABC. So again make use of perpendicular condition. So you will have two equations, solve for ABC and substitute back here to get the equation of any symmetrical form. So I hope you can do any problem based on this, right? Is it clear? See, suppose if they give this in general form, right? Find the projection or image. See, suppose in the exam point of view, if they give this line in general form, you convert to symmetrical form and follow the same procedure. If they give this line instead of symmetrical form, if they give in general form, convert the general form to symmetrical form and follow the same procedure, right? They can give the equation of line in symmetrical form or in general form. If they give in general form, you convert to symmetrical form, right? Okay. This is clear. This is the one set of problem that they will ask. Find the projection of line on the plane. So now we'll move on to second problem. I'll give you some exercise problem in question bank, but I'm not going to do one more problem in the same method. This is the procedure. Okay. We'll move on to problem number 2. So 2, 3, 4 are same set of problem. Find the prove that Prove that the equation of perpendicular from the point 1 comma 6 comma 3 to the line x is equal to y minus 1 by 2 is equal to z minus 2 by 3 or x minus 1 by 0 y minus 6 by minus 3. Dividing by 0 doesn't mean that it is infinity. Here it is meaning that this line has direction ratio 0, minus 3 and 2. Right? Don't think here given dividing by 0 means it is infinity. In this case, here 1 comma 6 comma 3 is a point on the line and 0 minus 3 2 is a direction ratio. And coordinate of foot of perpendicular is 1 comma 3 comma 5. Okay. And also let us add some more question, and also find the image of 1 comma 6 comma 3. Right? Let us add some more questions so that you have more clarity. So just understand the question. Very easy to follow. Right? Okay. So prove that the equation of perpendicular we have a point A which is 1 comma 6 comma 3. Right? We have a point A which is 1 comma 6 comma 3. So we have point A which is 1 comma 6 comma 3, and we have a line So prove that the equation of perpendicular from the point. So okay. So let's call this as B. This B is called the foot of perpendicular, right? This B is called the foot of perpendicular, right? So we need to find the equation of AB. Find the equation of perpendicular from the point 1 comma 6 comma 3 to the line L. L is this. We need to show that the equation of AB is x minus 1 by 0, y minus 6 by minus 3, z by 3 by 2. Prove that the equation of the perpendicular from the point 1 comma 6 comma 3 to the line are this. Also the coordinate of, okay, we need to find the coordinate of B and also find the image of A. So we need to find the image of A. Let A dash be its image. Right? Let us write it down. So let B be the foot of perpendicular and AB the point 1 comma 6 comma 3. So what we need to show equation of AB is, we need to show equation of AB is, because equation of AB is the equation of perpendicular. Prove that the equation of perpendicular from the point to the line. So we need to show equation of AB in symmetrical form is given by x minus 0 by 1. We need to show this, right? We need to show the equation of, we need to show equation of AB is this. So prove that the equation of the perpendicular from the point to the line is this. So x minus 1 by 0, y minus 6 by minus 3, z minus 3 by 2. So how to find equation of AB, right? How to find equation of AB, and also we need to find the coordinate of foot of perpendicular. We need to find the coordinate of B also, and also we need to find image also. Let that be a dash. Let that be a dash. Right? Okay. Now, how to find equation of AB? Right? How to find equation of the line AB? So we need to find equation of the line AB. Right? Okay. Now, what is L? So L they have given, right? They have given L as x minus 0 by 1, y minus 1 by 2, z minus 2 by 3. Let us say equal to some k. Right? So that is I'm going to find any point. What any point on the line will be of this form. I'm going to find the coordinate form. So that means x is k, y is 2k plus 1, z is 3k plus 2. So that means any point we need to find b, right? If I find b, then I can easily find the equation of AB because we know equation of line passing through 2 point. What is the equation of line passing through 2 point? It is x minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1. So I'm just going to find the coordinate of b. After finding coordinate of b, I can easily find equation of AB. How to find coordinate of b? If I find coordinate of b, I can easily find the coordinate of both of perpendicular also because both are same only. So how to find b? So any point on L is of the form k comma 2k plus 1 comma 3k plus 2. For some k, it will take b. For some k, it will take b. Okay, right? Okay, so we know any point on the L is of the form. Okay. Now, okay. So for some k, it will be equal to b, right? Yes. Now, what is the direction ratio of L? What is direction ratio of L? What is the direction ratio of line? 1 comma 2 comma 3. Let us find direction ratio of AB and make use of perpendicular condition, right? So we know direction ratio of L, right? Now, what is direction ratio of AB? Now, direction ratio of AB. What is A? A is the point that they have given, which is 1 comma 6 comma 3, and B is some for some k it will be b. So k 2k plus 1, k 2k plus 1, 6k plus 2, sorry 3k plus 2, right? 3k plus 2. So see, we don't know for some k b will take this value, right? Because any point on L is of this form. For some k b will take that value, but we don't know b. Let us take b to be this for some k, right? Now what is direction ratio of AB? It is x2 minus x1, x2 minus x1, y2 minus y1, z2 minus z1. So direction ratio of AB is k minus 1, 2k minus 5, 3k minus 1. This is the direction ratio of, this is the direction ratio, right? K minus 1, 2k minus 5, 3k minus 1, right? Okay. Now, what is direction ratio of L? We already know, right? They have given L, so this is direction ratio 1, 2, 3. Is 1, 2, 3. So we know AB is perpendicular to L. So that means corresponding direction ratio A1, A2 plus B1, B2 plus C1, C2 is 0. So therefore, we will have 1 into K minus 1, 2 into 2K minus 5, 3 into 3K minus 1 is 0. So we have K minus 1 plus 4K minus 10, 9k minus 3 equal to 0, 5k, 9k is 14k, minus 11 minus 3 minus 14. So we have k is equal to 1. So if k is 1, so we have found the value of b. So the b point is given by k k 2k 2k plus 1 3k plus 2. So if k is equal to 1, then only AB will be perpendicular to the line, right? So if k is 1, so the B point is given by 1 comma 3 comma 5. So 1 comma 3 comma 5 is the coordinate of the foot of the perpendicular. So we have found the coordinate of the foot. Okay, we need to show it is 1 comma 3 comma 5. We have also shown this, right? So you can see we need to show that the equation of AB is this and the coordinate of foot of perpendicular is 135, which we have easily shown. Is the coordinate of foot of perpendicular, right? Okay, now we need to find equation of AB, right? So equation of AB, what is A? A is 163, and what is B? B is the one which we have found, which is the coordinate of foot of perpendicular. What is the equation of line passing through 2 points? X minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1. You can take x1, y1, z1 to be this or that. No problem. Let us take this. So we will have x minus 1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1. This is what we need to prove. X minus 1 by 0, y minus 6 by minus 3, z minus 3 by 2. So we have shown prove that the equation of perpendicular from the point 1 comma 6 comma 3 to the line R, we have shown why they are given R, why they are given R. R means more than 1. If I take x1, y1, z1 to be this point, you will have some other equation of shape, but in different, but it is different. If I take x1, y1, z1 to be this, you will have x minus 1 divided by 0, y minus 3 divided by something. That is only they are given R instead of is. Sorry. Now, sorry. And also find its image of 1 comma 6 comma 3. So let A dash be the image of A. See, since this is perpendicular, midpoint of A dash is B. See, this is the property that image this B will always be the midpoint of its image A and A dash. So midpoint of A dash is nothing but B. So let us take, we don't know A dash, right? Let us say it is x2, y2, z2. So apply midpoint formula x1 plus x2 by 2. So 1 plus x2 by 2, y1 plus y2 by 2. So 6 plus y2 by 2, 3 plus z2 by 2 is equal to B. B point is nothing but 1 comma 3 comma 5. Now solve for x2, y2, z2. So we have 1 plus x2 by 2 is equal to 1. 6 plus y2 by 2 is equal to 3. 3 plus z2 by 2 is equal to 5. So we have x2 to be equal to 1. 6 minus 0, right? This is z2 is equal to 7. So 1 comma 0 comma 7. So A dash is 1 comma 0 comma 7 is the image of A. We project this on the line. The image of point is a point, image of line on the plane is a line. Is it clear? See, we have solved only 2 problems as of now, but it has taken time. But it is very important in conceptual point of view, right? It is very important in conceptual point of view. Let us have a 1 minute break 2-minute break, and then we'll continue. Still, I haven't had lunch. 2:30. Okay. Two terms are clear, right? It's a very important exam point of view. Let's have a 2 minutes break. Just a minute. Okay, so we move on to third problem. Find the same question. Find the length of perpendicular. Okay, so find the length of, see, if they ask you to find length of perpendicular in this question also, find the distance between AB. Right? If they ask you to find length of perpendicular means you just find the distance AB using distance formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Right? Okay. So find the length of the perpendicular drawn from origin to the line x plus 2y plus 3z plus 4 equal. Same question. Instead of the point 1 comma 6 comma 3, they have given origin here. So instead of 1 comma 6 comma 3, they have given origin here. Instead of the line in symmetrical form, they have given line in general form. And also find the equation of perpendicular. And also find the equation of perpendicular and the coordinate of foot of perpendicular. Again, very important question. The same as the previous problem, instead of the line in symmetrical form, they are given in general form. What we will do? We will convert this general form to symmetrical form and then do the same procedure. So here it is origin. We have a line. So we need to find this. This is B is the foot of perpendicular. So we need to find equation of AB, right? And also we need to find the coordinate of foot of perpendicular. They have given line in general form. So first what we will do is we will convert general form to symmetrical form. After that it is very easy, right? Same as previous problem only. So I think you know how to convert general form to symmetrical form, you can follow the same procedure, right? Okay. Now they are given in they have given an equation of line in general form, right? This is P1, this is P2, and this P1 has direction ratio 1, comma 2, comma 3, and this P2 has direction ratio 2, comma 3, comma 4. This is the line, right? Let us say this has direction ratio A, comma B, comma C. So to find equation of line symmetrical form, you should know direction ratio and you should know any one point or any one coordinate on that line. Now you can see this same, right? I'm not going to repeat. You know how to convert general form to symmetrical form. This line L lies on P2. So this direction ratio and this is proportional. This normal and this line is proportional. Sorry, perpendicular. So therefore, the corresponding direction ratio will satisfy A1, A2 plus B1, B2 plus C1, C2 equal to 0. So I'm not going to write the story. You know how to convert general form to symmetrical form. So I'm just going to solve the equation. So you will have A plus 2B plus 3C equal to 0, and you will have 2A plus 3B plus 4C equal to 0. Now solve for ABC, right? So we have 2, 3, 1, 2, 3, 4, 2, 3. So we have 8 minus 9 is minus 1, 6 minus 4 is 2, 3 minus 4 is minus 1. So one of the direction ratio is minus 1, comma 2, comma minus 1. So we know direction ratio of the line ABC, sorry, of the line L. Now we need to know any one point or any one coordinate. Let us substitute Z is equal to 0. So if Z is 0, you will have X plus 2Y equal to minus 4. And if Z is 0 here, you will have 2x plus 3y equal to minus 5. Now solve for x and y. Let us multiply 2 here. So we will have this will get cancelled. Minus minus plus. This will be 4y. So 4y minus 3y is y. It will be minus 8. Minus 8 plus 5 is minus 3. So we have y to be equal to minus 3. So if y is minus 3, we know x plus 2y is minus 4. So if y is minus 3, x is minus 4 plus 6. X is minus 2. Therefore, one point on the line is one coordinate. One coordinate is minus 2, minus 3 and 0. So you can write the equation of this line in symmetrical form. So x minus x1, y minus y1, z minus z1. Direction ratio is minus 1, 2 and a minus 1. So this is the equation of this line in symmetrical form, right? X plus 2, y minus 3. Okay. Now what we will do is, now follow the same procedure, right? So any point on the line will be of the form, let us say it is equal to k. So any point on the line will be of the form minus k minus 2, 2k minus 3 and minus k. So for some k, b will take that value. And again, what is direction ratio of AB? This now turns out to same as previous problem. Direction ratio of AB. A is origin, and we know any point on B is of the form, sorry, any point on the line is of the form minus k minus 2, 2k minus 3, minus k. For some k, B will take this value. Now let us make use of direction ratio. So x2 minus x1, y2 minus y1, z2 minus z1. Direction ratio is minus k minus 2, 2k minus 3, minus k. And what about direction ratio of the line? Direction ratio of the line is minus 1, 2, minus 1. minus 1, 2, minus 1. The line AB is perpendicular to L. So corresponding direction ratio A1, A2 plus B1, B2 plus C1, C2 is 0. So you will have K plus 2 plus 4K minus 6 plus K equal to 0. So this will be 6K. 6K minus 4 equal to 0. So 6K is equal to 4. So you will have K to be equal to 2 by 3. Right? K to be equal to 2 by 3. So if K is 2 by 3, what about the point B? Eight minus 1. Minus 4 is 2. 3 minus 4 is minus 1. Minus 1, 2, minus 1 is the direction. Z is 0. We have x plus 2y equal to 2x plus 3y equal to 5. Multiply by 2, so 4y minus 5 minus 8 plus is minus plus. Sorry. Uh, this is plus 2, right? Minus 4 plus 6 is plus 2. Sorry. It's 2 comma minus 3 comma 0. It will be x minus 2. This will be minus k plus 2. Sorry. So this will be minus 2. So it will be minus 8. Okay, plus 8. 8 by 6. So 4 by 3 is the value of k. So that means when k is 4 by 3, we can find the coordinate of b, right? So any point on the line is of the form minus k plus 2, 2k minus 3 minus k. So if k is 4 by 3, we will take this point. Therefore, e is given by 6 minus 4 is 2 by 3, 8 by 3. So 8 minus 9. So it is minus 1 by 3 minus 4 by 3. This is the coordinate of the foot of the perpendicular, right? So it is 2 by 3 minus 1 by 3 and minus 4 by 3. From now on, you can find all. So find the length of the perpendicular. So you know A, you know B. You just find the length of AB and also find the equation of perpendicular. We have found the coordinate of foot of perpendicular. Now what is equation of AB? That is equation of perpendicular is AB. So A is 0 comma 0 comma 0 and B is 2 by 3 minus 1 by 3 minus 4 by 3. So it is x minus 0 divided by x2 minus x1. y minus 0 divided by y2 minus y1, z minus 0 divided by z2 minus z1, and the length of perpendicular is nothing but magnitude of AB. So it is nothing but square root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. So we will have root of 4 by 9 plus 1 by 9 plus 16 by 9. Root 21 by 3 is the length of the perpendicular, and foot of perpendicular is 2 by 3 minus 1 by 3 and minus 4 by 3. Is it clear? The same problem as previous problem. Only thing is here they are given the equation of line in general form and the point is origin. So we are converting this to symmetrical form and doing the same procedure. We'll move on to fourth problem. Find the distance of the point. Find the distance of the point minus 2 comma 3 comma minus 4 from the line x plus 2 by 3, 2y plus 3 by 4 equal to 3z plus 4 by 5, measured parallel to the plane 4x plus 12y minus 3z plus 1 equal to 0. Right? So again, very simple problem, same as previous. So find the distance of the point minus 2, 3, 4 from the line. This measured parallel to the plane. Okay. See, if it is distance means you always find perpendicular distance, right? And always find shortest distance. So we have a point minus 2 comma 3 comma minus 4. So find the distance of the point from the line. So we have a line. Right? So find the distance of the point we have a point which is minus 2 comma 3 comma minus 4 and they are given a line L. So find the distance of the point minus 2, 3, minus 4 from the line, and this distance is measured parallel to the plane. So this distance is measured parallel to some plane. Right? This distance is measured parallel to the plane. Very easy, right? Okay, so first we need to find the foot of perpendicular. Then only we can find the distance of the point from the line, right? So same as previous, right? Same as previous. Now, first we will find the coordinate of foot of perpendicular. Then you find the direction ratio of AB. After that, we will proceed, right? Now, any point on the line, what is the L? So the given line x plus 2 by 3, 2y plus 3 by 4, 3z plus 4 by 5, let us say equal to some k. You will find any point on the coordinates form, right? You will find the coordinate form. So that means x plus 2 equal to 3k. So x is 3k minus 2. 2y plus 3 equal to 4k. So 2y is equal to 4k minus 3. So y is 4k minus 3 by 2. And 3z plus 4 equal to 5k. 3z is equal to 5k minus 4. So z is 5k minus 4 by 3. That means any point on the L will be of the form 3k minus 2, 4k minus 3 by 2, 5k minus 4 by 3. Now for some k, B will take that value. Now what is direction ratio of AB? Direction ratio of AB. We don't know the exact point of B. For some k it will be B. But let us say B is this for some k. So what is A? A is minus 2, 3, minus 4. And what is B? B is B is B is 3k minus 2, 4k minus 3 by 2, 5k minus 4 by 3. So what is direction ratio of AB? So it is x2 minus x1, 3k minus 2 plus 2, 4k minus 3 by 2 minus 3, 5k minus 4 by 3 plus 4. So we will have 3k, 4k minus 9 divided by 2, right? Minus 3 minus 6 is minus 9. 3 4s are 12, 12 minus 4 is 8. Now this is the direction ratio of AB, right? This is the direction ratio of the line AB. Now we can see, we know direction ratio, right? We know this direction ratio. Now what is the direction ratio of the normal to this plane P2? This is the normal to this plane, right? It is perpendicular to it. Now what is this direction ratio? What is the direction ratio of the plane? It is 4 comma 12 comma minus 3. Now you can see this direction ratio AB is perpendicular to that normal, right? We have AB is perpendicular to normal of the plane P. What is you know direction ratio of AB and you know direction ratios, right? So what is direction ratio of AB? So 3k, 4k minus 9 by 2, 5k plus 8 by 2, right? Sorry, 5k plus 8 by 3. And what is the normal of the plane P2? What is the normal of the plane P? It is 412 minus 3. So they are perpendicular. So that means 4 into 3k, 12 into 4k minus 9 by 2 minus 3 into 5k plus 8 by 3 is 0. Now solve for k. You will get the k value to be equal to 2. So if k is 2, B will take the value. So what is any point on the L is of the form 3k minus 2, 4k minus 3 by 2, 4k minus 3 by 2, 5k minus 4 by 3. So if k is 2, B will take this value. So 3 into 2 minus 2, 4 into 2 minus 3 by 2, 5 into 2 minus 4 by 3. So 6 minus 2 is 4. 4 2s are 8. 8 minus 3 is 5. 10 minus 4 is 6 by 3. So this is the point B, right? 4B point is 4 comma 5 by 2 comma 2. This is what we need to find, right? Find, okay, we need to find distance. Okay, find the distance of the point minus 2 comma 3 comma minus 4 from the line this measured parallel. So therefore we know B. So distance is, you just refer the diagram, right? Distance is nothing but distance between A and B. So A is minus 2, 3, minus 4. And B is the coordinate of foot of perpendicular, which is 4, 5 by 2, 2. Now apply distance formula. You will get the distance as 17 by 2. Right? So very easy problem. So all three problems are very similar problems. Right? Okay. So we'll move on to next problem. Next problem is one set of problem. See, the first problem is one set. That is, we are projecting a line on the plane. Next three problems are one set, right? So it is based on finding the finding the foot of the perpendicular coordinate and equations. I'll move on to fifth problem. Okay, so we'll move on to fifth problem. Again, this is very important problem. Find the equation of straight line. Find the equation of straight line passing through the point. So passing through the point 1 comma 2 comma 3 to intersect the straight line. To intersect the straight line. To intersect the straight line. To intersect the straight line, x plus 1 is equal to 2 into y minus 2 equal to z plus 4 and parallel to the plane and parallel to the plane x plus 5y plus 4z equal to. I'm going to do one problem based on this. I'm going to do one problem as exercise. So find the equation of straight line passing through the point 1 comma 2 comma 3. So we need to find an equation of plane. Sorry, line. We need to find the equation of line that has to pass through the point 1 comma 2 comma 3. Right? It has to pass through the point 1 comma 2 comma 3. Let us say L is the line we need to find, right? It has to pass through the point 1 comma 2 comma 3 to intersect the straight line. So this line should also intersect this line L1 and this should be parallel to this plane. So we need to find equation of L, that L has to pass through 1, 2, 3. It has to intersect L1 and this L has to parallel to x plus 2, x plus 5y plus 4z is equal to 0. So very simple. So what is to find L, right? So just look at the diagram, right? You write some stories based on the diagram. So we need to find equation of L. Now you can see it passes through 1 comma 2 comma 3. So we can write in symmetrical form, but we don't know direction ratio. So let us say equation in symmetrical form is x minus 1 by a, y minus 2 by b, z minus 3 by c. Let us say equal to some k, where ABC is the direction ratio, where A comma B comma C is direction ratio of the line L. So solve for XYZ. So any point on L will be of the form AK plus 1, BK plus 2, CK plus 3. Right? Now what about any point on L1 is of the form? So what is L1? So L1 is x plus 1 by 1. Let us say a symmetrical form. Y minus 2 by 1 by 2, z plus 4 by 1. Let us say equal to some. We already used k, right? Let us say equal to some t. Because any point will be of this form only, this like this, right? Okay. So what about L1 coordinate will be of the form t minus 1, t by 2 plus 2, t minus 4. So that means any point on L will be of this form and any point of L1 will be of this form t minus 1, t plus 2, 2, t minus 4. Now they are intersect means they should be equal. So L1, L intersect L1. That means both the coordinate has to be same. That means AK plus 1, comma BK plus 2, comma CK plus 3 is equal to t minus 1, t by 2 plus 2, t minus 4. So we are in the process of finding the direction ratio, right? Okay. Is it clear up to now? Okay. Now solve for ABC, right? Now solve for ABC. So you just solve for ABC, right? So we have AK plus 1. AK plus 1 is equal to t minus 1. BK plus 2 is equal to t by 2 plus 2. CK plus 3 is equal to t minus 4. Now solve for ABC. So you will have AK plus 1, BK plus 2. So we have this to be equal to this. So A is, you just bring this 1 to that side. So you will have t minus 2 by k, right? So A is t minus 2 by k. B is, now solve for B. So t plus 2 minus 2. 2 2 will get cancelled. 2 2 will get cancelled. So that means B is t by 2k, right? T by 2k. Sorry, t by 2k is. That only, right? T minus 1, t by 2 into t2, t4. So this will be, so you will have ck is equal to t minus 7. So you will have c to be equal to t minus 7 by k. T minus 2 by k. Yes, so this is the direction ratio of the line ABC, right? But we need in numbers, no problem. See, we need to find equation of L. This is the required equation, right? But we don't know ABC. Only thing is we need to find ABC because we know already we know a point on the line. If I know direction ratio, I can easily find equation of L. The only thing is we don't know ABC. So to find ABC, what we are doing is any point on this line will be of the form K. So any point of L is of the form and any point of L1 is of this form. Since it intersect, both has to be same. Therefore, ABC direction ratio of L is given by A comma B comma C. So T minus 2 by K, T minus 2 by K, comma T comma 2K, T comma 2K, T minus 7 by K, T minus 7 by k. This is the direction ratio of L. Now you can see again this this line will be direction ratio of this plane will be perpendicular to L, right? So we have direction ratio of the plane is perpendicular to L. What is direction ratio of the plane? Direction ratio of the plane is 154, 154, and direction ratio of the line is t minus 2 by k, t by 2k, t minus 7 by k. So a1 a2 plus b1 b2 plus c1 c2 is 0. Right? Now just take LCM and solve for k. That's it. Solve for this. Let us multiply into 2 into 2 into 2 into 2 so that LCM will be 4k and take that to that side. So we have 2 into t minus 2 plus 5t plus 8 into t minus 7 is 0. If we will have whole divided by 4k, take that to that side. So we will have 2t minus 4 plus 5t plus 8t minus so, so 2t plus 5t plus 8t. So you will have 15t minus 60 equal to 0. So 15t is equal to 60. So you will have t to be equal to 4. Right? So that's it. So we have found ABC. So substitute this t here. So direction ratio of L is, so t is 4. So 4 minus 2 by k, 4 by 2k, 4 minus 7 by k. So direction ratio will be 2 by k, 2 by k minus 3 by k. Right? So 2 by k, 2 by k minus 3 by k is direction ratio of L. Therefore, equation of L is from start. So we don't know this ABC, right? So x minus 1 by a, y minus 2 by b, z minus 2 by c is equal to k. So what is a? A is 2 by k, y minus 2 by 2 by k, z minus 2 by minus 3 by k equal to k. So let us take that 1 by k to that side. So k will get cancelled. So we will have x minus 1 by 2, y minus 2 by 2 equal to z minus 2 by minus 3. So you can take this 1 by k, 1 by k to that side. So we will have k into 1 by k. This is the equation of line in symmetrical form, right? This is the required answer. See, very simple. Only thing is we don't know direction ratio. Only thing is we don't know direction ratio, right? See, find the equation of straight line. This is the we need to find L, right? Find the equation of straight line. Let that be L. And has to pass through the point 1, 2, 3 and intersects the straight line. Let this be L2 and it is parallel to the plane. So we have three data here. So the equation of line passing through a point is x minus 1 by a, y minus 2 by b, z minus 3 by c. ABC is the direction ratio of L. We know direction ratio. For that, we are using the condition that any point on this line will be of this form, any point on the line L1 will be of the form. Since it intersect, both has to be same, and the direction ratio of this plane is perpendicular to L. All these conditions will give you the answer for direction ratio, right? Okay, now I'll give you one exercise problem based on this same Same exercise problem. Sixth problem is exercise problem. Same question. Only thing is I'm going to change the answer. Find the equation of straight line. Find the equation of straight line passing through the point passing through the point P comma 1 comma 2 to intersect the straight line x plus 4 equal to y plus 1 is equal to 2 into z minus 2 and parallel to the plane 4x plus y plus 5z equal to 0. So same question, right? Only thing is there is a difference between the two lines and the planes, right? Same question. They will take this as exercise. You can do this, right? So still we want to do four more problems, right? Still we want to do four more problems. Still we have four more problems left. After that we will wind off straight lines, right? After that we will have uh, straight lines. Find the equation of this. You can do this, right? So I haven't had a lunch yet. So I will take the lunch and then I'll come back after 10 minutes, right? So I'll take some 10 minutes lunch break. Let us resume the class at 3:20, right? Still four more problems. I can finish that in 30 minutes, but it's getting late for lunch, right? So I'll have that. Taking lunch break. Right? The class will resume at 3:25. So yes, so we'll move on to seventh problem. So still we have one more problem. Yes, so first what we'll do is we'll finish up these three problems and then we'll move on to two more problems, right? Okay, so we'll finish up to problem number 11. So first we will start with this problem. So again, very simple. So find the equation of line that intersects the, see, they are given two lines, we need to find an equation of line that has to intersect both the line, right? Find the equation of line which intersects both the line. So we have, they are given two line L1 and they are given L2. So we need to find an equation of line that intersects both L1 and L2, right? Okay, very simple problem. So the required equation is given by, so equation of a line that intersects two line is given by, I'm going to find this in general form. I'm going to find this in general form. So this line is in general form and this is also in general form, right? Now the required line is given by, it's very simple. So in order to find L, what you have to do is see, you have, so you just put 2x plus lambda times y plus 2z. See, you just combine these two plane with lambda, right? And similarly, you combine those two plane, we will have x plus 3z minus 4 plus some new times 2x plus 5z minus 8 is equal to 0. This is the required equation of in general form. You have two planes, right, for general form. The only thing is you need to solve for lambda and mu. Only thing is you need to solve for lambda and mu. So how to get this equation? Very simple. P1 plus lambda P2, P1 plus mu P2. Now solve for these two equations. Now you can see it passes through very simple, right? In order to find the equation of line that intersects two line, that equation of in general form is given by this, right? Let's put lambda plus put lambda. So it passes through 2 comma minus 1 comma 1, 2 comma minus 1 comma 1. Substitute this here. You will have two equations, right? So you will have substitute this here and here. You will have two equations in lambda and mu. Solve for lambda and mu to get the required answer. So you will have substitute this here. You will have what? 2x plus y minus 4 plus lambda times y plus 2z equal to 0. So 4. So you will have minus 1 plus lambda is equal to 0. So we have lambda to be equal to 1. And similarly substitute this here, x plus 3z minus 4 plus mu times 2x plus 5z minus 8 equal to 0. So 2 plus 3 is 5, 5 minus 4 is 1, 4 plus 9, 4 plus 5 is 9, 9 minus 8, 1. So we have mu to be equal to minus 1, right? So substitute back here, that will give you, so therefore L is given by, 2x plus y minus 4, 2x plus y minus 4 plus lambda times y plus 2z equal to 0, comma, general form we should have two plane, x plus 3z minus 4 plus mu times 2x plus 5z minus 8 equal to 0. So lambda is 1, mu is minus 1. So you will have 2x plus y plus y. So 2y plus 2z minus 4 equal to 0. X minus 2x is minus x. 3z minus 5z will be minus 2z minus 4 plus 8 equal to 0, right? This is the required equation of L. So you will have, if you take these two outside, you will have x plus y plus z minus 2 equal to 0. And this is same as x plus 2z minus 4. This is the required equation. So very simple. If you want to find an equation of L that passes through L1 and L2, So just find this is the required equation in general form. So we will have one plane, we will have other plane. Just put lambda mu. It passes through. So find lambda and mu. Right? Okay. Similar problem is 8th. So find the equation of line that intersects both the line. So they have given two lines L1 and L2. So we need to find a line L that intersects both L1 and L2. So the required equation L is given by 2x plus y minus 1 plus lambda times x minus 2y plus 3z is equal to 0, comma. The other is 3x minus y plus z plus 2 plus mu times 6x plus 5y minus 2z minus 3 is equal to 0. In the previous problem, it is mentioned that it passes through some point. So if we substitute that, we will have two equations in lambda and mu. So here instead of that, it is given that it is parallel to the line. So it is parallel to the line. So this line is parallel to what? This line x by 1. These two are parallel. X by 1, y by 2, z by 3. Right? So if it is parallel means the normals are perpendicular. Right? If it is parallel means the normal will be perpendicular. See, I can write this. This is same as so 2 plus lambda into x plus 1 minus 2 lambda into y e z into lambda plus constant term minus 1 equal to 0. Right? Just combining this. Similarly, here we have 3 plus 6 into mu x minus 1 plus I mu into y 1 minus 2 mu into z. One constant term here is 2. 2 minus 3 mu equal to 0. Right? 2 minus 3 mu is equal to 0. Now it is parallel to x by 1, y by 2, z by 3. This has direction ratio 1 comma 2 comma 3. If it is parallel means these are planes. So it will be perpendicular to that, right? So it will be, you just have to visualize this, right? It will be perpendicular to, let us call this as 1. It will be perpendicular to 1. So we will have a1, a2 plus b1, b2 plus c1, c2 into 0. So 2 plus lambda into 1. 1 minus 2 lambda into 2. See, this is our a2, b2, c2. This is our a1, b1, c1 plus 3 lambda into 3 equal to 0. So from this you can find the value of lambda. You will get lambda to be equal to minus 2 by 3. Now similarly it will be perpendicular to this as well as it will be perpendicular to this also. Now make use of this condition. So 1 into 3 plus 6 mu minus 1 plus I mu into 2, 1 minus 2 mu into 3 equal to 0. So you will have mu to be equal to minus 2 by 5. So substitute, this is a required equation, right? Substitute lambda and mu, you will have two planes. Substitute lambda and mu in star, you will get L in general form. That's it. See, in order to find lambda and mu, the previous problem it is mentioned that it is passing through a point, but here it is mentioned that See, just visualize this, right? Just visualize this. It will be very easy. See, we have two lines. It is perpendicular to normal. It is not perpendicular to. It is parallel to this line means it will be perpendicular to normal. Very simple. You just draw diagrams for both. You will get the required. See, if it is this means, let's say this is some more plane. So they have given L1. They have given L2. So we need to find an equation that intersects both the line. So let us say this is the line L, right? This is the line L. Now this line has to this has to be parallel to this line. X by 2, y by 2, x by 1, y by 2, z by 3, right? So this plane 1 has direction ratio 2, 1, 2, 1 minus 1. This has direction ratio 1 minus 2, 3. This has direction ratio 3 minus 1, 1. This has direction ratio 6, 5 minus 2. Now you can see they are perpendicular, right? And their corresponding normals are perpendicular to this line. That is only using this condition. A1, A2 plus B1. So you can see this normal is perpendicular to this line. That means A1, A2 plus B1, B2 plus C1, C2 is 0. Because of this only we have got this as lambda and mu. Right? See, only very simple only. Everything is same concept. You just have to visualize this. That's it. So we'll move on to ninth problem. Find the equation of two planes. So you need to find the equation of two planes that has to pass through origin, which are parallel to the line at a distance of pi by 3 from it. So we need to find an equation of two planes. So let us say this is one plane, this is one plane. Let's say this is one more plane, right? It is passing through origin. Let us say this is our origin. So both the planes are passing through origin, and it has to be parallel to the line L at a distance of 5 by 3 from it. This distance is 5 by 3. This is what we need to find. So we need to find the equation of two plane. Both the plane has to pass through origin, and it has to be parallel to the line L at a distance of 5 by 3 from it. Right? A distance of 5 by 3 from it. Okay. So still only one more problem left. So we'll finish this quickly. Right? Okay. Now what is the equation of plane passing through origin? It is ax plus by plus cz is equal to 0, right? Because equation of plane passing through x1, y1, z1 is a into x minus x1, b into y minus y1, c into z minus z1. Here x1, y1, z1 is 0, 0, 0. So you will have ax plus by plus cz plus dc. So this is the equation of plane passing through origin. Now we need to find equation of two planes, right? Okay. So both has to pass through origin, and it has to be parallel to the line L, and it has to be a distance of 5 by 3 from it, right? Okay. Now, if this plane is okay, so let us say we don't know this, right? We don't know the direction ratio of the first plane P1, as well as we don't know direction ratio of second plane P2, but we know direction ratio of the line, which is what? 2 comma minus 1 comma minus 2, right? This is the direction ratio. Again, you can see they are perpendicular, right? So let a comma b comma c, let a comma b comma c be direction ratio of the plane P. I'm just saying P. It can be P1 or it can be P2 also. So they are proportional, right? Sorry, they are perpendicular, right? So P is perpendicular to L. P is perpendicular to L. So we will have A1, A2 plus B1, B2 plus C1, C2 is 0. So this P has direction ratio A comma B comma C, and this L has direction ratio 2 comma minus 1 comma minus 2. So we will have 2a minus b minus 2c equal to 0. All this as equation number 1. Right? 2a minus b minus 2c from 0. Now the distance, okay, we need to, they have given that it is at a distance of 5 by 3 from the line, right? Okay, it is at a distance of 5 by 3 from it. So we have a plane, we have a line, we have a plane, right? This distance is 5 by 3. The plane is ax plus by plus cz is equal to 0. The distance is 5 by 3 from it. See, we know any point on the given line. So any point on the line is what? Any point on the line is 1 comma minus 3 comma minus 1, right? So we know any one point is 1 comma minus 3 comma 1. So we know distance is 5 by 3. So what is the distance formula? This modulus of ax1 plus by1 plus cz1 divided by root of a square plus b square plus c square is equal to, we have given this 5 by 3. So x1, y1, z1 is 1 minus 3 minus 1. So we will have, this is our x1, y1, z1. So we will have a minus 3b minus c divided by root of a square plus b square plus c square is equal to 5 by 3, right? So we will have a minus 3b minus c divided by root of a square plus b square plus c square can be plus or minus 5 by 3, right? Because this is modulus. If this value is equal to 5 by 3 means it can be plus or minus 5 by 3. See, we need to solve for ABC, right? So if I solve for ABC, this is the required equation of plane passing through origin. If I solve for ABC, I can get the answer. We have got, already we have got one equation, 2a minus b minus 2c is 0. Now here you will get one more equation, solve those two to get the value of ABC, that's it. You will have two values of ABC. At this way only we will get two planes. So you just solve this, right? So you just solve this. So you will have, let's multiply 3 to that side. So we will have 3 into a minus 3b minus c is equal to plus or minus 5 square root of a square plus b square plus c square. Now make use of this condition. Make use of this condition. 2a minus b is 2c. From this you get a. From this you can find b to be equal to 2a minus 2c. Substitute b here. You will have solve for a and c. You can do anything. See, you just have to solve for a, b, c. That's it. From here we have got 2a minus 2b. Sorry, 2a minus b minus 2c is 0. And here we have got this, right? So you just take this as two equations. One is plus 5, other is minus 5. And you just try to take b to be equal to 2a minus 2c and substitute b to be 2a minus 2c. You will have an equation in AC. Now solve for elimination method. You can find the value of ABC. Getting my point, right? So you just split this into two equations, right? So one, case two. So case one is 3 times a minus 3b minus c is equal to 5 times root of a square plus b square plus c square. Now put b to be equal to 2a minus 2c. So you will have an equation in terms of AC. Now solve that. Right? In that way, you will have the value of ABC, right? This is very simple. You can do that. So you will have, when you do that, or when you do some simplification, you will get the values to be equal to A is equal to, just a minute. When you solve this, right? When you solve this, When you solve this, you will have A is equal to C by 2, B equal to 2C, right? B is equal to 2C. This is what you will have, right? A is equal to C by 2 and B is equal to this is what you will have. So from this you can get the value of ABC, right? From this you can get the value of ABC. That's it. A is 2C. Okay. What we will do is, so okay, I'll do this, right? No problem. Let us say it is equal to plus or minus 5 itself. Let's say is equal to this equal to plus or minus 5 itself. I will do this, right? Now what I will do is squaring. So square this, so you will have 9 into a minus 3b minus c whole square. This will be plus 25 a square plus b square plus c square, right? Don't split into case 1 and case 2. I will do this. So just square this, you will have this. Now what I'm going to do is I'm going to put a to be equal to b plus 2c. Substitute a to be equal to, so what is a from here? So we have 2a is equal to b plus 2c. So a is b plus 2c by 2, right? So just put a to be equal to b plus 2c by 2. Now solve again. So 9 into, you will have an equation in terms of BC now, right? Because everything is in terms of BC only, right? So a is b plus 2c by 2 minus 3b minus c whole square equal to 25 a square. So b plus 2c by 2 whole square plus b square c square. Now solve this, right? You know, you will solve this, you will get this equation. B plus c into b minus 2c equal to 0. Right? Just solve a plus b whole square and so on. So that means b has to be minus c or b has to be 2c. So case 1. Right? So case 1, if b is minus c, what about a? A is b plus 2c by 2. So if b is minus c, so we will have a to be equal to c by 2. Right? So we have a to be equal to c by 2 and we have b to be equal to minus c. So that means we just combine this. A is c by 2, b is minus c. So what is the equation of plane? Ax plus by plus cz equal to 0. A is c by 2, so c by 2x, b is minus cy, cz equal to 0. So let us take c outside. So we will have x by 2 minus y plus z equal to 0. So c not equal to 0. So x minus 2y plus 2z is equal to 0 is one of the plane. Right? X minus 2y plus 2z equal to 0 is one of the plane. Now similarly, you will have one more plane also, right? In case 2 is a very simple problem only. Just practice this problem, very important problem also. So don't think that since I am doing this class, it is not important. Very important problem. So you need to find equation of two plane, right? So one plane is this, the other plane is case 2 when b is 2c. So when b is 2c, so what we know a is what? A is b plus 2c by 2. A is b plus 2c by 2. So when B is 2C, we will have 2C plus 2C by 2, which is 2C. So we have B to be equal to C, A is 2C. Equation of plane is A plus BY plus CZ is equal to 0. So A is 2C, 2C into X. B is again 2C plus C that is equal to 2 plus C outside. So we will have 2x plus 2y plus z is equal to 0. So since c is not equal to 0, 2x plus 2y plus z is equal to 0. This is the plane P2. So this is the equation of two plane which we need to find. Both pass through origin. Both pass through origin, and it lies at a distance of 3 by 2 from the origin. Right? Very simple problem. You just have to solve. That's it. So we'll move on to the last problem. Straight lines. This is based on shortest distance, which we discussed in the previous class. Find the shortest distance between the line and the shortest distance between the lines x minus 1 by 2 equal to y minus 2 by 4 equal to z minus 3 and and y is equal to mx, sorry, y minus mx, y minus mx equal to z equal to 0. For what value of m? For what value of m will the two lines intersect? Will two lines intersect? This is the last problem I'm going to do, right? So we know you already know the shortest distance between the two line formula, right? L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. So first can write both lines symmetrical form. So we have L1 is x minus 1 by 2, y minus 2 by 4, z minus 3 by 1, and L2. So you just have to write this in symmetrical form. So we have y is equal to mx, z is equal to 0. Write in symmetrical form. So that means x is equal to y by m, that is equal to z. Right? So we have this is symmetrical form. X by 1, y by 1, sorry, x by 1, y by m, z by uh, z by sorry z equal to 0. That means z by 0. So this is how you write in symmetrical form, right? So x by 1, y by m, z by 0, right? So dividing, it is not dividing by 0. This is direction ratio 1 comma m comma 0. So you can see, so we have two lines L1 and we have two lines L1 and L2. We know shortest distance nothing but the perpendicular distance, right? So this PQ is the shortest distance. It passes through the point 1 comma 2 comma 3. See, we already explained in previous class itself. And this passed through the point 0 comma 0 comma 0. And this has direction ratio 2 comma 4 comma 1. And this has direction ratio 1 comma m comma 0. So PQ is the shortest distance. So what is shortest distance? PQ is the shortest distance, which is given by L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1, where x1, y1, z1 is this point, x2, y2, z2 is this point, right? And L comma m comma n is the direction ratio of PQ. So you will have x2 minus x1. See, you can split, you can change this L1, L2 also, right? Um, You will have minus L, you will have minus L, minus 1, minus 2, minus 3. No problem, distance only, right? Will be just positive. Y2 minus Y1, Z2 minus Z1. You can write minus 1, minus 2, minus 3, or that also work on distance only. So it is L plus 2M plus 3N is the shortest distance, right? What is LMN? Where L comma M comma N is the direction cosine of the line PQ. So first let us assume that this PQ has a direction ratio A comma B comma C. Now this PQ is perpendicular to L1. PQ is perpendicular to L1. So this has direction ratio A comma B comma C. This L1 has direction ratio 2 comma 4 comma 1. That means they are perpendicular. So you will have 2A plus 4B plus C equal to 0. Now similarly, this PQ is perpendicular to L2 also. And this PQ has direction ratio A comma B comma C. This is direction ratio, right? Not direction cosine. And this L2 has direction ratio 1 comma M comma 0. Again they are perpendicular, so we will have A plus BM plus 0C equal to 0. Solve for ABC, you can get the direction ratio. Solve for ABC, you can get the direction ratio. So you will have A divided by B divided by C divided by, so 4 1 2 4 4 1 2 4 B 0 1 B. So you will have minus 3. So you will have 1. You will have 2B minus 4. So that means one of the direction ratio is given by minus B comma 1 comma 2B minus 4. But we need to find direction cosine. So you just have to normalize this, right? That means minus B divided by root of. So just find the value of B. It will be B square plus 1 square plus 2B minus 4 whole square. B square plus 1 plus A square minus 2 times AB plus B square. So you will have 5B square minus 16B. So you will have 5B. Sorry. It is M, not B. Sorry. Because coefficient of B is M, right? Because we are finding coefficient of ABC only. M. So minus M divided by, this is M square, right? M. So you will have M square plus 1 square plus 4M square minus 16M plus 16. So you will have 5M square minus 16M plus 17. This is the, here this normalizing this minus M divided A, L comma M comma N is A divided by root of A square plus B square plus C square. So 1 divided by root of 5M square minus 16M plus 17 comma 2M minus 4 divided by root of 5M square minus 16M plus 17. This is the direction cosine. Therefore, the shortest distance is given by, we know shortest distance, right? It is L plus, this is the shortest distance, L plus 2M plus 3N. So L plus 2M plus 3N. So just have to add. So you will have minus M plus 2 plus 3 times 2M minus 4 whole divided by root of im square minus 16M plus 17. So 6M minus M is 5M. 3 minus 4 is minus 12. Minus 12 plus 2 is minus 10 divided by root of 5M square minus 16M plus 17. This is the shortest distance, right? So find the shortest distance between the two lines. So they are not given directly in symmetrical form. Let us try to write that in symmetrical form, right? So that is the shortest distance. For what values of m, the two lines intersect. If two lines intersect means if two lines intersect, shortest distance will be 0. Yes or no? So that means you just equate this to 0. So you will have 5m minus 10 divided by root of 5m square minus 16m plus 17 equal to 0. So that means 5m minus 10 is 0. 5m is equal to 10. So when m is equal to 1 by 2, this will intersect. If m is not equal to 2, you will not intersect. That shortest distance will be given by this. Is it clear? That's it. So we will wind up this session. After the session, I will give you the practice problems, question bank for straight lines. So this is very important class. You just practice these 10 problems. This is very simple, right? This we already discussed in previous class. Shortest distance formula. Only thing is it is in terms of m. Here we have coefficients to be equal to m instead of number. So depending upon m, this is the shortest distance. It will intersect when m is equal to 2. So we will finish off. So we have completed 3 topics in analytical geometry. In the next class, we're going to start spheres, right? So in the next class, we're going to start spheres. If you haven't joined Telegram group, join our Telegram group. So we'll see in the next class. Thank you. All the best.